Turn over to the sideboard, please, and thank you. Algebra 1, Fun Talk Friday we just had, which is lit. Okay, on the 6th of December, SWBA students will be able to, as you guys, write equations of parallel and perpendicular lines, section 4.8. Heads up, guys, this is our last section of our notes, okay? We finish this off. We just have this little half page of notes. Boom, back is blank, okay? Boom. And we're going to be looking to test next Thursday, heads up, okay? Chris.
What are we doing all classes? We're like almost done with the notes.
Work time.
Awesome.
Okay.
Well, we're just gonna.
Kelly, that was your
play
question?
ball.
No, it's like you said that we weren't almost halfway done. We are. It's like we did A yesterday.
Wait,
We are halfway done.
Everyone's
Corrected.
wrong.
We're more than halfway done.
Yes.
When are we gonna take our finals?
Yeah.
Why we taking
Not
not
halfway
halfway
done
done
with
four?
No,
With
we're
four
taking
uniform.
finals.
We're not halfway done with uniform notes. We're done. We're almost done with.
Yeah, with the 4.8. Okay. So guys, let's look at the first part of 4.8a. Now we started that last time. We gave ourselves a head start on that one. Okay. So we can be like, hey, this way we consider ourselves up for success. So I'm just gonna recap these. Okay. And I'm gonna have you guys help me recap them. So we talked about parallel lines. Okay. Parallel lines are lines that do not what? Intersect. They don't intersect. What was our symbol for it, guys?
Two diagonal lines.
Yeah, it was two like slashes, right? Wait a second.
Backslash.
That's
You're on the
labeled
wrong
wrong.
There we go. Let's try this again. Okay.
Oh.
Parallel lines do not intersect.
Same.
Not wrong.
Symbol of parallel line is those two slashes. They look like too many parallel lines, and they have the same slope. Exact same slope because right there, let's say that's line, if it's going to be parallel to it, well, those slopes are both positive, but aren't they the same? No, so eventually what's going to happen? They're eventually going to cross and intersect, but if they have the exact same slope, okay, they have the exact same slope here, okay, pretend that has the exact same slope here, okay, those will never, ever, ever cross, but only if they increase at the exact same rate. Was that a sneeze or a cough? And then we talked about these, so write equation in slope-intercept form. Line that's parallel to the given line goes to the point. We did both examples 1 and 2?
Yes.
Okay, let's recap example 1 here, okay? So what we had to do was, if we needed the equation in slope-intercept form parallel to the given line, goes to the given point. We're given the point, but we also need slope. So we say, well, what's the slope of this line? It's -5. So what's the slope of our parallel line going to be? -5. So then we went in, we said, okay, y minus 3 is equal to -5 times x minus 2. We use point slope form with the point we know it has to go through and the slope of this line. It's similar to what we did on our graph. This time we're doing the equation side of it rather than the graphing side of it, okay? And we went through and we did our 2 steps from there to solve for y to get this in slope-intercept form. And we ended up giving ourselves y is equal to -5x plus 13, correct? Now, when we got to number 2, right, we had to do something else to get our slope right because we didn't have our slope right away. So in order to get our slope, we had to solve for y first, okay, if we remember that. Okay? Because it was important that we had our slope from this equation, so we knew our parallel slope was the same, so we can use point slope form. Questions on those two? Okay, that's parallel. So now we're going to do section B here, which is what? Perpendicular, okay? So perpendicular lines intersect at what kind of angles? Right angles, right? We talked about that last chapter, last unit 4A. They intersect at right angles, not like right and left, not right and wrong, okay? Right angle just means it's a 90-degree angle, okay? The symbol for perpendicular, guys, is going to look like this. It's going to be like an upside-down T, okay? You might be asking Mr. Russell, why, okay? Well, that's a great question, math students. Thank you for asking why, okay? Well, it's kind of like this. If I do this, we can show that those lines are perpendicular, okay? And a way we mark that, does anyone know a way we mark perpendicular lines? Seth?
Right angle.
How do we mark a right angle?
Little square.
Little box thing, right? Little square thing there. Okay, that shows that's a right angle. It tells anyone that's looking at it that's a right angle, okay? But here's the thing. If I do a little symbol like that with all the arrows, that's kind of annoying, okay? And if I shorten it down, something like this, what does that look like in math? Plus sign. So that's going to be really confusing. But do we ever use upside down T? No. And that kind of just looks like it's the top half of that. So this is still a perpendicular line. You don't see it going all the way through, so we're just kind of missing the bottom half of that. That's fine by us, okay? So that's why the symbol's that way. Now the slopes of perpendicular lines are what of each other? We said this before. Opposite. So they're opposite signs.
Opposite slopes.
Opposite signs. What else do we do? We change the sign, and what else do we do? That's the
Flip it.
opposite. We flip it. What's it called when we flip it? It's the
Reciprocal.
reciprocal. Okay? So they're opposite reciprocals of each other. Okay? Meaning that if one's positive, one has to be negative. One's negative, it has to be positive. Okay? And if you flip the fraction. So we're going to do the same kind of thing we did on examples 1 and 2, or for A, and examples 1 and 2 for B. Write an equation in slope-intercept form is how we want it, of the line that is perpendicular to the given line and goes through the given point.
There's one thing that's the same about perpendicular and parallel.
What's that?
Slope intercept.
Okay, so we still want our equation in slope-intercept form. Yeah, we do tend to favor slope-intercept form. Okay? So, here, where you have y is equal to negative 3x plus 2, and we have this point. We're going to have to use this point here. So what form we're going to have to use if we're using a point? Point slope form. Okay, somebody remind me what point slope form looks like. Okay, we talked about this one a lot, Lucas. Very good. And I am going to ask that we have that one memorized. Okay, I'm going to ask that we have that standard and slope intercept memorized. It's a lot to memorize, but I'm believing you guys. Okay, so thank you, Lucas. Though that was very good. Okay, so we're going to have to use this form. So what else do we need then besides our point? We need our
Numbers.
slope. Okay, for point slope, you need point and slope, hence point slope. Okay, so do we know the slope of this line though? What is it? Negative 3. It's already solved for y. So the slope's whatever's with the x there. So the slope is negative 3. So now, how do we find the slope of our new line that we actually want to find the equation of? You do the opposite reciprocal. Okay, before parallel lines, same slope. This time, the slope of our perpendicular line. So I'm going to put a little perpendicular there. Say, hey, it's a perpendicular slope here. What's it going to be? Negative 3 becomes what? Okay, positive, and it becomes 1 over 3. Is negative 3 secretly over 1? And so we flip it, we get 1 over 3, and it becomes positive. Okay. So now, can somebody help me set this one up? Put it in point slope form. Okay, thank you, Ben. Try again. 1 minus 4 equals 1 over 3. Very good. Y minus 4 equals 1 over 3 times x minus 2. So after we find the perpendicular slope, we have to make sure we put that. Okay. If we put in the negative 3, the original slope, we're going to find a line parallel. We don't want parallel, we want perpendicular. Okay. Questions on how we set that up? From here, how do we get it into slope-intercept form? Distribute. We have 2 steps. One of them is distributing. Y minus 4 is equal to 1/3 x minus what? What's 1/3 times negative 2? 2/3. Negative 2/3. We need to offside, no shame in that by any means. Encourage it. No cross reducing, so we just multiply straight across. Okay. What's our second step?
Get everything on left side.
Add 4. So since you're actually implementing standard form. So as you go 1/3 x, what do we have to do with this 4? Put it over 1. Put it over 1 and get common what?
Denominator.
Denominator. It's going to be our common denominator, guys.
3.
3. Okay, so multiply the bottom by 3, and what else we do?
12.
Top by 3. Okay. So we distributed, Kenny?
Yeah.
Then we added 4 to both sides. We got everything common denominators. Okay. So now we can do y is equal to 1/3 x minus 2/3 plus 12/3. So y is equal to 1/3 x plus what? 10/3. That's our answer. So if we were to graph those two lines, guys, we'd see that they're perpendicular. If we were to graph those two lines, we'd see that they're perpendicular. Yes.
What happens if your lines are neither parallel or perpendicular?
Then you did it wrong. So that's kind of off. Can I actually show you the two graphs of these lines real quick and show you that they are parallel or they are perpendicular? I'm gonna go ahead and do that. So we have these we have graphing calculators that we can use, and there's online ones actually too.
Thank you.
Disgusting. Just more. Mr. Castle,
Mm-hmm.
would you like to try some birthday cake gum?
Honestly, I'm intrigued. Look at first.
Same here.
The rainbow flavor was good. But birthday cake gum.
I'm more of a mint guy myself. But
Same.
you know, that's just me.
I didn't. Landon's mom did. She gave me and him a ride home and she bought a bunch of them. It was.
Okay, guys, here's our graph.
Oh my god.
So we see here, the blue is our new one that we made. The red's the original. And do those look to intersect at a right angle there?
For sure.
Kind of.
Uh-huh.
They do.
I do my.
I would say they do.
Can you put on a right angle?
Okay, I would say these totally do. Okay,
It's disgusting.
especially if we get going closer.
Can I ask you guys to do that next one on your own?
Maybe. It's not terrible. It's not great. Might be possible. It's neither.
It's like when I wait for you to
It's not kind of disgusting. I can't. I'm sneezing with. Bless you and bless the rain down there. Bless you forget.
Isn't it
Two
lest
jokes
you
at the
never
same
forget?
time.
Isn't it lest you never forget?
I thought it was bless you forget.
No, last week.
Oh.
So close.
Doesn't matter. Leslie, you forgot?
So is this, are you, like, why am I so good?
Yeah, I know you don't think you're talking.
Huh?
I know you don't think you're talking, but you are.
What?
No, it's every time.
I have a meme that represents my life.
Are you talking right now?
Probably, I don't know.
Okay, when you're done or have questions, I want you to raise your hand. Okay, when you're done or have questions, I want you to raise your hand.
What's the chances that we'd be on this? Yeah.
Yeah. And then you're gonna be going every time you call. You're gonna have to like drink it. Huh?
It's like hard because I'm
It's just a really big mouth. Like, got a whole year left. I don't know. I mean, oh wait. Oh, I see. I don't see it. Oh no, I do. Okay, okay.
solve for y. Once you find y, then you can find the slope. Then you can find the
So you're adding 4y raised to 3x.
So I'm gonna get y by itself, so I'm gonna move this across.
I have would you like a piece of gum? This has just it's like the worst gum in the world. Looks just like a little like accent. Like
So how do we find
getting
the
off
slope?
on here, just grab them. Not throwing gum at you.
You get
Water. Yeah.
No airborne objects, Elliot.
You just want the force here.
Called airborne.
I don't even know like how to work in my. Did I start off right?
Hey guys, we're gonna talk about the beginning part of this up here, okay? So, in order to start off, what do we need to find? Our slope. We need to find slope. So we need to get this in slope-intercept form, okay? Finding slope from here is not the easiest thing in the world, okay, necessarily, okay? Unless we use our shortcut we learned yesterday, that's what last time, that's okay. We're not going to use that one very often because we won't remember that one very often. Trust me, I know that. Okay? So, we get this in slope-intercept form. So what variable do we need to solve for? Y. How do we solve for y? What do we have to move? X. So how do we move this 3x?
Subtract your X.
Negative 4y is equal to what?
Negative 3x plus 7.
Very good. Okay. What's one more step to get rid of, to get y by itself? Divide by negative 4. Y is equal to, well, negative 3 divided by negative 4, that's 3 over 4. 7 divided by negative 4 is negative 7 over 4. Now, at the end of the day, do we really care about negative 7 over 4? No. Why? What do we really just need from this equation?
Slope.
Slope. We don't care where this line goes past that. We just need to know the slope of this line. And why do we need the slope of this line?
So we can find the slope of the other line.
So we can find the slope of the other line. And the slope of the other line, the perpendicular line, will be what then?
Negative
4 over 3.
Negative 4 over 3 because it's the opposite. Positive becomes negative, and the reciprocal 3 over 4 becomes 4 over 3. Yes, Bailey?
Is it okay if I accidentally like the 7 first and then like the negative like 3x when we were writing the problem?
Yeah, we just have to keep in mind that we want whatever's with the x there, okay? But we really like to try and keep it in the form where x comes first, okay? So if you wrote the negative 7 over 4 first, then I would at the end just kind of switch it back. Does that make sense? Good question. Thank you for being patient with that. So now we found this slope, right? Okay? Wait.
I wrote the same thing as you, but I didn't write it this time.
Okay, can I do that? Oh.
Ben did it wrong and he's pretending like he did.
So this isn't part of the this not isn't part of the equation. This is the line. This is the Let's try that through. So because we don't actually really care what this is, that's why.
Hi Mom, are you looking at shoes this?
Because it didn't mess with our x.
What year was she born?
Does that make sense?
She's only 36.
She's not a
mentioned
mom.
that she
Yeah,
was
thanks for
born.
asking. Okay. So now that we know the slope, and we don't care about the rest of this equation in reality, what can we do? I know the slope, what can we do? Put it in point slope form using the point we're given. Okay, using the point we're given here, okay? We're given this point here, and we need to use that. Okay? We know it needs to go through this point and be perpendicular to this line. We already found out how to make it perpendicular because we made it the opposite reciprocal slope. So now I just need to go to this point. So can somebody help me plug this into point slope form? Okay, can somebody help me plug this in to point slope form? Let's head up, please. Okay, Ryan, I'm gonna call on you, buddy.
Oh, I know.
Y plus
Okay, yep.
Equals negative 4/3, negative 4/3 times x minus.
Exactly right. Thank you, buddy. So y plus 1 equals negative 4/3 times the quantity of x minus 3, okay? It ends up being y plus 1 because minus a negative becomes a positive there, okay? Questions on plugging that in a point slope. Let's see, must train that out, let's forget. Now from here, is this a problem we've done a handful of times?
Many.
Yeah, it is, okay? Because we're solving for what now? No, we're solving for what now? Let's see, must train that out, let's forget. We're solving for slope-intercept form, meaning we're trying to get what variable by itself?
Why?
Y, okay? So we have how many steps to do this?
A lot.
How many steps do we need to get there?
To
2. Reese, what's our first step?
Distribute.
Distribute, very good. Y plus 1 equals negative 4/3 x. Hey, this third and this 3, that might work out nicely. We can do it off the side if we want. Cross reduce. Negative 4 times negative 1 is positive 4. So that's one of our steps. What's our second step here? Nate, Nate, what's our second step?
Subtract the 1.
Subtract 1. Y is equal to negative 4/3 x plus 3. And that is the equation of a line that is perpendicular to the given line, and it goes through the point. So we met our qualifications. Those were the conditions that we were given, and we met each and every one of them. Questions on that one? Yeah, we are going to do the examples at the bottom. Okay. Are these two lines parallel, perpendicular, or neither? Parallel, perpendicular, or neither, okay? Quick adjustment on number 1. You guys have that big old blotted out back. So what should that be? 1/2, okay? So it's y equals negative 2x plus 6, and y equals 1/2 x plus 16. And we're asking the question, are these parallel, perpendicular, or neither? Does anyone have any ideas? Raise your hand if you have an idea. Okay? Raise your hand if you have an idea here, okay? Think about this one. Think about how we can figure this out, okay? Okay? Seeing some more and more hands. As we keep thinking about this more, this is awesome. I love it, okay? Okay. Whitney, what are you thinking? Okay, why do you say perpendicular? Are you making a guess? Oh. What has opposite reciprocal? The x. So what is with our x? The m. What's m stand for? Does anyone help her out? Slope, okay? M stands for slope, okay? So what's the m or the slope of this first line? -2. What's the m or the slope of the second line? 1/2. Now those are opposite reciprocals of each other. So if the slopes are opposite reciprocals of each other, Whitney's exactly right. These would be perpendicular. You could write out the word or you could just put the symbol. Okay? And our proof, and when it says explain, okay, telling me the slopes and just saying, hey look, they're opposite reciprocals. That's a great explanation. Say, hey, they're perpendicular and they're opposite reciprocals. That's why. So when it asks us to explain, that's a good enough explanation for us. Okay? Other people that raised your hand, was that the same thing you were going to say?
Yeah.
Okay. Yes, Seth. If you're doing the second one, don't blur. Is that what you're doing? Okay, thank you. Okay. Okay, does that make sense? Cool. Okay. On the second one, do we know the slopes right away? No, but can we find them? How? You can't find them? Nope, all hope is lost. Okay. We gotta get what, Kenny?
Gotta get Y by itself.
Whoa. You gotta get y by itself, okay? You gotta get y by itself here, okay? So, I'm gonna ask you guys to get y by itself on both of those and figure out whether these are parallel, perpendicular, or neither. And I'm gonna ask you guys to You get y by itself on both of those. So we know the slopes. So we know whether they're parallel, perpendicular, or neither. We have to look at the slopes to know that, okay? So go ahead and do number 2 on your own, please, and thank you. Okay? If you have that or have questions, I want you to raise your hand. What's our explanation for that? Why they're neither. Why? So let's explain that. But that find a way to raise it. Remember, when you have it or have questions, I want you to raise your hand. So helps us find our slope. Big picture right here. Nice. Perpendicular also needs to be what? Yeah, are they? So what do you think these are instead? Are they? They're the same? Kind of. Say that again. And why? Not the intercept, actually. What are we looking at? We're looking at the. Are those the same? Are they opposite reciprocals? No, it's not perpendicular. You can just write that. Yes. Yeah.
Yeah, because she has him in her visor.
These two have everything.
Benny Kelly.
Constable, would you like to try one or my don't?
One of your gums.
Over here.
One of
That
your
sounded
gums.
It's like good, but then it's terrible.
Sounded really
No, it's just always
When
bad.
it's good, it's kind of good.
Chris, you should
but
try
then
one.
it's bad,
I'm
it's
good.
really bad. So like,
It's just weird.
You
That
smell
was
it?
the cost of what happened, what perspired at your house. The lawnmower incident.
Oh yeah, Chris went really fast with my lawnmower and blew out the transmission.
Oh, were you guys trying to make it fly?
Yes, we were trying to make it fly.
Oh yeah, he also dumped 3 2-liters into my hot tub. What?
Tell them all the whipped cream.
We shot a whipped cream container.
Shot, we ate. We each ate like a whole can of whipped cream.
No, remember mine fell over.
I ate them all. You shot it.
I said it.
Hey guys, let's make sure we're respecting those that are working. Voices off, voices off.
you're supposed to smile. So that was
So, anything, so how are they paired? How are they anything else other than that, those two would be other than here's the kind of slope we choose. Okay, we're gonna go ahead and talk about this one up here. Hey guys, I want everyone's attention up here. I know you guys have the worksheets out. I want everyone's attention up here still real quick while I explain this one. So here we end up solving for y in both of these. So 3x equals 2y minus 6. Okay, so I can add 6, okay. 3x plus 6 equals 2y, divided by 2. Y is equal to 3 halves x plus 3. If we're more comfortable with that, we'll switch it around. Y is equal to 3 halves x plus 3. So the m is 3 halves. Over here on this one, okay, 9y minus 6x is equal to 3. Add the 6x. 9y is equal to 6x plus 3. Divide both sides by 9. Y is equal to, well, 6 divided by 9 simplifies to 2 over 3. X. 3 over 9 simplifies to 1/3. What's the slope of this line? So we say, okay, as we're going through and figuring out if they're parallel, perpendicular, neither. For them to be parallel, what would have to be true? They have to be the same. Are they the exact same?
No.
No, so they're not parallel. What would have to be true for them to be perpendicular?
What would have to be negative?
They have to be opposite and reciprocal. Are they both opposite and
No.
reciprocal? No, they're just reciprocal. So are they perpendicular? No. So what does that leave? What option does that leave? Neither, okay? So if it's anything else, if it's anything other than the exact same or opposite reciprocal, it's neither. So you can say neither, they're not the same, and they're not the opposite reciprocal. So they're not the same and they're not the opposite reciprocal, okay? They're different slopes, but they're not opposite reciprocal, okay? Something like that. Okay, so if it's anything other than that, anything other than those two options, it's neither, okay? So regardless of whether it's reciprocals or whether they're the same signs, if it's anything other than those two options, same or opposite reciprocal, it's neither. So on the worksheet, on those first 8 you guys have, on like 3 through 8 there, okay? when you're going through there, completing the table, on some of those, you need to go through and find the slope. That's why there's more work on. That's why there's a lot of space for work on that page. Is because you'll probably need it to find the slopes. Okay, you'll probably need that space on your worksheet to find your slopes. Okay, so that's why I put that there. Okay, questions on that? Thank Dope and Liddy.